Hello, everybody. I hope you're having a great day. Today, we're going to look at unit rate as slope. Um, so, you're going to need to add to your journals today. So, make sure you pull out your journal or you get a notebook and start a journal. So, interpreting the unit rate as slope. First, we're going to look at some definitions. Rate is the comparison of two quantities that have different units. For example, we could compare miles and hours. Then we have the unit rate, which is a rate in which the second quantity in the comparison is 1 unit. So 60 miles, or for my one example here, 65 miles per 1 hour. My next one is 65 cents per 1 pound. And we would just say per pound or per hour. All right, so I'm going to have an example here. All right. So we have Misty Mountain Storm, and here's our graph that represents in hours how much snowfall we got in inches. And here it says, remember that slope is a constant rate of change. So it says find the slope of the graph using the points 1, 2, and 5, 10. So, and I've marked those points here on the graph that we're using. And then I've labeled them x sub 1, y sub 1, x sub 2, y sub 2. And then I have substituted those values into my slope formula. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. 10 minus 2 is 8. 5 minus 1 is 4. We need to simplify that and we divide. 8 divided by 4 is 2. So our slope of this line is 2. Then it says find the unit rate of snowfall in inches per hour. So my unit rate is 2 inches per hour. Which point in the graph tells you the slope of the graph and the unit rate of change in the snow level? And that point is this 1, 2. And that is because the second quantity hour is 1. It's giving us our unit rate. Next, we have graphing proportional relationships. The note here, remember the constant of proportionality for a proportional relationship is the same as the slope. So if it's going through the origin, your constant of proportionality is going to be the same as your slope. Okay? You can use a table and a graph to find the unit rate and slope that describe a real-world proportional relationship. Here's an example problem. Every 3 seconds, 4 cubic feet of water pass over a dam. Draw a graph of the situation. Find the unit rate of this proportional relationship. So I have step 1. We need to make a table given this information they're telling us. We're getting 4 cubic feet per 3 seconds. And then all I did was expand that out. Up 3, add 4. Step 2, draw a graph. So we are able to plot those points and draw a graph. Step 3, find the slope. You can use rise over run, or you can grab 2 points from here. It doesn't matter which way you do it. And I have 8 is my rise and 6 is my run. I can simplify that, divide both those by 2, and I have 4/3. So my slope is 4/3. The unit rate of water passing over the dam and the slope of the graph are equal. So our slope is 4/3. Our unit rate is 4/3 cubic feet per second. So the value is not changing. What's changing is we're adding our units here for our unit rate. Okay, we've got one last page, and it's using slopes to compare unit rates. All right. The equation y equals 2.75x represents the rate in barrels per hour that oil is pumped from well A. The graph, so we have a graph right here, represents the rate that oil is pumped from well B. Which well pumped oil at a faster rate? So I have the equation here for well A, and then well B is this graph. So step one, we're going to use the equation y equals 2.75 to make a table for well A's pumping rate in barrels per hour. So we know this was our slope, right? That's our rate of change, 1 in 2.75, 2 in 5.5, 3 in 8.25, and 4 in 11. Okay. Step two, use the table to find the slope of the graph of well A's rate. My unit rate and my slope are the same thing, and all we've done here is just said that each of these, because we have a constant rate of change in here and in here, this constant rate of change means when I simplify those, I will all end up the same thing. So my slope is 2.75, and my unit rate is 2.75 barrels per hour. Step three, use the graph to find the slope of the graph of well B's rate. And what I did here, and I've identified it right here, you can see, and we're going up by twos, so when I go up 2, 4, 6, 8, 10, and I run to 4. So 10 over 4 is 2.5 barrels per hour, or 2.5 barrels per hour. Then I need to, step 4, compare the slopes. 2.75 is greater than 2.5, so well A's rate, 2.75 barrels per hour, is faster. Make sure you're taking these notes. I'm going to do journal checks coming up soon, and take your time and use them when you're working on the assignments, and have a great day.